So let's get going. Hi there, I'm E. Dunham. I do ops for the research team at Mozilla, which means a lot of Rust, a lot of Servo, and a little bit of whatever other research projects find out that they have an ops guy around and their infrastructure's on fire. So you can get all of these slides and a bunch of other slides at talks.edunham.net, so don't worry about like copying down any URLs. I'll have this up at the end too, so you can just...
posting it to the links?
I will post it to my thing after this. I will post it to my session on Linux Fest as well. So, we're here to talk about Rust, the awesome new programming language. How many of you kind of hope this would be a Rust tutorial by a show of hands? Whoa! Everybody's here for the community automation stuff. That's awesome. Last time I gave this talk, like half the room was just like, I want to talk about Rust, please. So, let's skip right into it. Rust started its development in earnest in about 2010, and it was picking up speed gradually until Rust 1.0 came out on May 15th, 2015. So we're up to our first birthday of the programming language coming up very soon, and we've rolled a release every 6 weeks since then. That was the initial commit by Graydon, the founder of the language. So the goal of Rust is to provide a systems programming language pursuing this trifecta: safe, concurrent, and fast. So when we say systems programming language, we mean something that you can talk straight to your hardware with, something you could realistically hope to write an operating system on or to run on a chip with very limited resources. So people will often say, oh, it's Go versus Rust, it's Rust versus whatever. Many of the languages that Rust gets compared to are actually meant for higher level applications. Sometimes they'll call themselves systems languages in the sense that they're for sysadmins to work with, which is just kind of confuses the issue. But basically, Rust does this with a system of ownership, borrowing, and lifetimes. It enforces a whole bunch of rules about how you're allowed to manage memory in order to take away your ability to make a lot of the mistakes that make C and C++ code often vulnerable if you're not perfect and if you ever slip up. So this little guy, he's the Rust mascot. His name is Ferris. He's a Rustacean. There's stickers of him up here if you want. You'll see him throughout the slides, just helping me do visuals. There's a whole lot to say about how Rust works, but I'm not going to get very far into that, other than to say that if you imagine there's a set of all valid programs that don't let you access memory you're not supposed to, programs that don't just randomly crash on you, most programming languages will accept and happily compile or happily start running programs totally outside of the scope of those valid programs. Whereas safe Rust will only let your program compile if it can convince itself that it won't have certain problems. So we call this zero cost abstraction for getting for guaranteeing certain traits about a program's safety at compile time, so it doesn't slow your program down. The cost to the zero cost abstraction is a learning curve. So I'll skip through our syntax bits. Basically, the point of giving some syntax demos here is to A, sate the parts of the audience that are here for a Rust programming tutorial a little, and B, prove that the compiler is really smart and can figure out a lot of things for you. I've heard it said that most programming languages we use today are based on the things that we knew in the 60s about programming. And Rust is just, let's use some of the things we learned in the 70s. Let's not do anything too outrageous, too cutting edge. Let's do the things that have been researched and proven for decades, but they're just ever so slightly newer ones of them. So if someone wants to get Rust, there's a couple ways to go about it. If you just want to run some Rust code in your browser without using any extensions or anything, you can go to play.rustline.org, or you can use the multi-Rust tool to install it, or depending on your platform, if you just want one version, you can just download a tarball or a binary from the Rust language website. We release on 3 major channels, which here's the first real community point, is that when we announced stable Rust, about a year ago, we posted a blog post saying we commit to stability. We need to be able to explore and experiment and run into these dead ends, but at the same time, our users need a language that's not just going to regress on them. So our promise is to ensure that you won't dread upgrading Rust. And toward the end of the talk, we'll get into exactly how we've implemented that. So it's cool, it's a programming language, it does neat stuff, it has technical merits. But what are people actually saying about it? They're saying, fortunately, perhaps the most impressive aspect of Rust is the welcoming community that supports it. This community could be Rust's not-so-secret weapon. My favorite quote about the community is that it seems to be populated entirely by human beings. I have no idea how this was done. Here's how it was done. In my opinion, as someone who joined the project about a year ago and has been working full-time in close proximity to the amazing wizardly compiler hackers that built everything, I think the way we did this is automation. And this may be because my definition of automation is offloading a human task onto a machine or onto a system. And in other words, I think of this as teaching some system a habit. It's a settled or regular tendency or practice, especially one that's hard to give up. If I write a script that will automatically do a thing at a given time, I've taught my computer the habit of doing that thing. If I manage to convince my community that the best way of going about a certain process is one that facilitates this awesome community, that's also, I think, a form of automation. And basically, this makes life better than I've seen it in a lot of other communities that I've been involved with. The first thing that a lot of communities will struggle with is diversity. Having people of different backgrounds, people of different opinions, and people who have wildly different priorities about where they should be going and what they want to do. And I will contend that having actual diversity of thought in a project is what causes nearly every conflict. Having diverse priorities is what causes people to argue with each other. And in most projects that I've been involved with, there is this tendency and this temptation for those disagreements to evolve into basically this verbal trial by combat. It's not, let's settle this by asking for moderation. It's not, let's settle this by examining the technical merits. It's, let's settle this by argument. And Rust just cuts that off before it can even start with this document. It's the code of conduct. I know that font is small, but I have the whole thing there to show you that it fits on a page. It's half conduct, don't be a jerk, be constructive, and half moderation. Here is precisely how and what will happen if you are a jerk, or insist on being unconstructive, or insist on fighting about things rather than solving them and resolving them civilly. So the code of conduct basically, in my opinion, sorts everybody into two kinds of people. The kind of people who are willing to resolve their disputes through moderation, and the kind of people who don't think that that's an option. So this is everywhere. You cannot participate in the Rust ecosystem without it. If you get onto IRC, it's right there in the topic. You get onto the subreddit, it's right there in this giant orange bar. If you get onto the discourse instances, which we use to do most of our communication the way a project would use a mailing list, it's right there. You can't even make your first 2 posts without getting reminded by this giant yellow pop-up, hey, code of conduct is in place. Just a quick side note about that. What about the mailing lists? We don't actually have any. We use Discourse entirely because it's this cool open source project. We can pay them a little bit of money to host it for us, and it allows a level of moderation that you really can't get on a mailing list. Most of what people do with a list is reading the archives. Discourse not only makes it easy to read the archives, but makes it incredibly easy for the moderation team to just yank abusive or spammy or problematic content. So it's all over the place. You can't get away from it. So how do people feel about this code of conduct thing? Great quote from this. I would attribute it to him, but unfortunately they posted it as Anonymous Coward. The Rust community gives me a particularly bad feeling. They're rather tyrannical about enforcing their code of conduct. They even have a moderation attack squad to go after anyone they deem to be an enemy. I've never seen this kind of orchestrated control exerted over the community of any other programming language. This sets off warning alarms for me. I'm going to contend that we might not have wanted a person with these attitudes to participate in our community. And the community definitely runs a whole lot more smoothly because people with these views have self-selected away. They've said, I will never use Rust because of this code of conduct. And we don't have to argue with them anymore.
I think the slash dot in that URL kind of says it all, though.
Yeah, I hear that there's a lot of that kind of conversation in programming-related threads on 4chan. I haven't managed to catch a screenshot of them yet because I haven't gone digging for them. But I hear that it's a sentiment echoed in a lot of parts of the internet that one would expect potentially problematic community members to come from or to participate in. So the big disclaimer here is that this works great for Rust because we've had it since before we were cool. Somebody at the end of this talk, I'm sure, is going to ask me about how a big established project can get a code of conduct into place. That's super hard. I don't know the answers there. But I do know that it's been working really well since we've had it, since everyone who's currently in the project either agreed to it or joined with the acceptance that it's going to be there. So we have people who agree on the very basics of how they're going to communicate with each other, how they want to build code. How do you figure out what to build? Most places, you just kind of guess. You're like, oh yeah, that would be a cool thing. Oh yeah, there's an issue open kind of related to that. I'm going to spend a whole bunch of time building this thing, and then I'm going to send you a pull request. And then they don't take the pull request. This feels terrible. You also kind of get this habit of using pull requests welcome as the synonym for I don't want to explain why that's a bad idea. It's probably too hard. If I tell you to implement it, you probably can't. And then if they invest hours of their life in it, they feel really bad. I have this hypothesis. The amount it hurts to be told that your code is like bad and you should go away is directly proportional to how much time you spent investing in that code. So if we're going to have to reject somebody anyways, if we can cut them off before they've invested a whole lot of time, they'll just kind of be like, oh well, maybe I should do something else, as opposed to being sad or even actively angry about it. For this, we have automated by training the community that the only way to get a major feature in is to go through the request for comment process. This process is implemented on GitHub. Everything is public about it, about the request for comment themselves, the conversation on them, and the notes of the meetings in which the core teams for Rust will discuss them. And another thing that helps here is that you don't get quite as attached to your code when it's a, I think this might be a good idea, and you have to spell out that it's just a suggestion, as if it's actually a thing that you've seen work on your computer so far. So, in this great big community, this is one of the ways that we can bring people together from all over the world to kind of converse about what's going on. But it's not the only one. And in a sufficiently large community, it can get really easy to kind of feel left out and not really get involved. To kind of keep people on the same page, keep people up to date about which requests for comment are going on, and so forth, we have a weekly newsletter where we pick out a whole bunch of neat things that are going on. A couple of things I'd like to call out that we emphasize here are the list of new contributors and another thing that's coming up, which are Friends of the Tree. The new contributors are cool because you kind of get to see your name in lights when you start getting involved. That's a huge encouragement. And we do this Friend of the Tree thing from time to time. We recognize people who've made outstanding contributions. These can be in docs, these can be in community management, as well as just being in code. And that's a nice community thing, but why do we call it that? Why Friends of the Tree? Why not like Outstanding Rustation or something? And this is because the state and the health of the tree itself, the code base that Rust is built on, is essential. You cannot break the tree. What happens if somebody pulls the latest master branch of the Rust repo and tries to build it and it won't? Well, a developer is going to have a bad experience. They're going to potentially lose faith in Rust. We're likelier to produce a bad release or a bad nightly that somebody's going to download and try to run some code and the code will fail and they'll feel bad. It's bad for the public image if word gets around that a whole bunch of Rust code just doesn't work. And it's bad for everybody's confidence in the project. And I think the most important part of this talk is what we do to address this. It's called the not rocket science rule, and it was invented by the original founder of the project. I think he had quite a lot of good ideas. The not rocket science rule says you automatically maintain a repository of code that always passes all the tests. This may sound like enlightening, or this may sound like, well, yeah, duh, that's what you're supposed to be doing, like we've had this forever. So it actually takes a huge amount of work to keep the tree green, as I'm sure you know, and that's where the automatically comes in. So when you try and keep your build always working, what kind of dynamic do you get? You kind of get a bunch of newbies or less expert people trying to get this code in, and a bunch of really kind of harried experts going, no, you can't do that, you can't do that, you can't do that. And it's people versus people, and it really feels bad for the newbies to get told no by somebody they respect. And it really feels bad for the people who are constantly having to do that triage to have to be telling the newbies, no, you can't do that all the time. It's really discouraging. So we've made this tiny, easy modification that totally changes this dynamic. Instead of us against us, it becomes us against the robots. This changes the conversation from, like, Brian says you can't do that, to Brian is helping you overcome the robot problem, or helping you understand why the robot said no. And it puts everybody on the same side, and I think creates a much more positive kind of interaction than you'd get from having a person arguing with another person about these things.
Dem Skynet.
Damn Skynet, yes. So who is this us? Let's look at how some code contributions break down. This is just like percentage of commits for the Rust Lang repo. Somebody's got like 30.8% of all the commits as of when I took the screenshot. Somebody called Boars. Let's have a look at Boars. What's Boars actually doing? Boars is posting these formulaic messages with this kind of glowy red icon. And you know, that name kind of rings a bell. Boars is a robot character from a sci-fi novel. I'm used to the paradigm where it's newbie versus maintainer. And Boars personifies the maintainers and automates the maintainers to the point where it's us versus Boars instead. What he actually does is, if a pull request is new and somebody adds a review on it, he will change its internal state. If the pull request is approved, he will run a test on it. He'll run the full test suite. If the tests pass, he will merge the code. And if the tests fail, he'll tell you what went wrong and wait for you to tell him what to do about it. It's super simple. It's a workflow pretty similar to what other tools like Gerrit will enforce. But Boars bolts straight onto GitHub instead. Now, we're not actually using the original Boars anymore. He had some problems. The original Boars ran on a cron job, and eventually we had way too many pull requests for that to be a sane model. So a community member, Barasel, wrote this bot called Homu, who is more stateful, integrates with GitHub triggers better instead of needing a cron job. He can do roll-up and try builds, so if you have a bunch of little fixes that need to be tested together, they can all just be combined. And just because we like simplicity and everything to be straightforward, the account name is still Boars. So if you see Boars making comments on GitHub, like I showed you earlier, that's actually a Homu in the background. If you want one of these guys who'll go off and run your tests for you, auto-merge when you R+ a commit, you can either host one yourself from that repo, or you can go to homu.io, and if it's up, then Barasel maintains a public one. So another thing you might have noticed in the Boars logic is that underneath all this, we're running a BuildBot instance. And having chosen BuildBot, I could complain about this tool all day, having to deal with it a lot. But one of the excellent things about BuildBot that you won't get in all CI systems is it allows people to bring their own bots. So we can have kind of a pull requests welcome attitude to platform support. We have one community member who's really passionate about Rust working well on BSDs. And we don't have the resources to maintain BSD infrastructure, but he can contribute he runs, I think, 2 or 3 different flavors of BSD build slaves that connect to our BuildBot instance, and then whenever they're up, all the tests will get run on them. So that choice has helped us automate away the argument about platform support to a certain extent. So far, we have gotten nice humans by using a code of conduct to weed out the people who don't want to play by our rules. We have shown them that we appreciate them by automatically publishing stats about the newest contributors and by not having to be particularly mean or particularly critical of them thanks to the bots. And we have kept the tree from breaking. These are pretty much the important parts. And with just these guarantees, yeah, question?
You said you show stats for new users, or new contributors? Is that just like people who haven't contributed before and started within a certain amount of time, or is it?
Yeah, so the question is, we show stats for new contributors. What are those like? In the weekly This Week in Rust report, it's just people who landed their first commit during the past week. There are some tools that community members have built, and then I've slapped some more glue on them to run them over all the repos instead of just one repo that'll do stats on like who's putting how many commits, who's putting how many merges, that kind of thing. I can get you the links to those are actually in the notes for these slides, which I'll post on my talk description. So all of these guarantees that we've got so far make it a pretty cool project. They're kind of the baseline. But the result of having this state in the project is that everybody wants to get involved. And so there's no such thing as too many new contributors, but in other communities, I've seen the core people become just gradually more and more grumpy and burned out as they have to answer the same question over and over and over, because all of the different newbies just kind of blur together to them. And it stops being, oh, newbie A said this and newbie B said that, oh well, but why do the newbies never know this thing? And it's not pleasant for anybody involved. So we've looked at the tasks that the long-term maintainers have to do a lot with interacting with the newbies, and we've automated a few of them. First one here is a spot called High Five. The task is when somebody new submits a pull request, you got to notice that they're new to the project. You've got to say hi to them, tell them who's going to look at their pull request, ping whoever it is that should look at their pull request, and possibly help out that reviewer by saying, hey, look at these files that they changed. So High Five is a bot that does all that. It looks kind of like a person. I mean, Rust's High Five has a high five gesture and everything. If you want your own High Five, you can either run a clone of the Rust or Servo High Five forks, or you can check out MentionBot that Facebook has published on GitHub, which does most of the assigning a reviewer to a pull request type tasks. So our High Five lets you configure who you should ping or assign based on what area of the code the pull request is to, which Rust needs because the Rust repo is such a large project. And the Servo project also has one which they've kind of diverged. They started off similar and then got independent work done on them. It's an ongoing project to try and end up with one High Five at the end. So the next problem is that even if your newbie kind of gets somebody assigned to them, or even before they make their first pull request, a new contributor is not really going to know what to do. They'll be like, what should I work on? What's hard? What's easy? Please tell me. Please tell me what to do. And after a while, that just gets exhausting to people who know what the tickets are. So using GitHub's issue triage system, we've made a site. Actually, Martin Fecky, who's a community member on the Servo side, wrote this starter site, and I'm showing you Servo's because their issue tags are a little bit better for making sure that we always have stuff to show. The Rust project has advanced to the point where fewer of the open issues are actually easy for a new contributor. So this just scrapes GitHub issue tracker and does the right query to say, is it easy? Is it in the language they're looking for? Okay, I'll show it to them all pretty. And this can save a lot of time for people dealing with newbies who are like, I want an issue. What issue should I do? Well, what languages do you know? What kind of thing do you want to work on? I know some Python, and I don't think I have good enough Rust. Well, okay, here's the Python query in the starters repo. So we also have a whole bunch of community code and community developed libraries. And I find this interesting because this is a place where this not rocket science rule of we should always maintain the repository of code that always passes all the tests jumped from being the compiler should pass its own tests to how can we test the compiler between major releases? How can we test what we're doing to the end users themselves? And so there's a definition of broken that we get from the promise that we made about how it shouldn't be painful to upgrade Rust, which is if your errors or warnings or results in any way from running the compiler on a given piece of code change from one stable release to the next, that's a pain point for the user. So Brian Anderson wrote this tool called Crater, which looks through all of the community libraries, the crates, which there's a lot of them, and runs a stable candidate on everything, and runs the old stable version on everything. And so if the errors match between the two versions, regardless of what they are, then we know that the new release hasn't messed anything up. But if the errors differ between versions, we know that something changed in an unexpected way. We need to either make a pull request to that crate and fix it, or we need to examine the stable candidate and figure out what we did wrong. And this helps us focus our release process on making everything work right for everybody. So again, we're just automatically maintaining the repository of code that always passes all the tests.
What is
Yes.
an error in the previous release and no error in the current release generate a bad result?
So this is testing whether the compiler made unexpected changes. So the bad there just means that we need to look at that. We need to make sure that was intentional. This could have really been an improvement, or it could be that the old compiler was catching some subtle bug that a refactor in the new compiler has caused it to cease catching. So bad there means it needs human attention. We need to figure out exactly why that happened and whether it's something that we should have done. So I figured I would leave myself some time so that we could look over the actual tools and I could answer the particular questions about applying community automation tools that all of you have about your various projects. So there's also an evaluation link. It was a faster talk than I anticipated. And yeah, so what questions do you have? How would you like to use this kind of tooling?
Can you hook?
Oh, yeah?
So I guess my question would be: so let's say you detected the crate, Samsung crate, didn't have any errors.
Mm-hmm.
That with a new major version of the compiler,
Mm-hmm.
it actually started seeing errors. It means human needs to take a look at that
Mm-hmm.
crate, right?
It might
so would
be.
it be like Rust
Mm-hmm.
core team developer or crate one?
So the first person to look at that, the question is, let's say a crate goes from having no errors in one release and then it starts having errors in another release, and we notice that in a Crater run. The first person to look at that will probably be Brian, because he runs Crater. It will be a core team maintainer, and they'll look and they'll go, is this the crate's fault? Was that a bug that we just weren't catching before? Or is this our fault? Have we introduced a problem in the compiler? If he sees that, oh, the crate was just doing something wrong and we didn't catch it, then if it's a larger, widely used or currently maintained crate, he'll probably file an issue or even a pull request against it to inform them. And this won't scale indefinitely. As we get more and more crates, we'll probably have to apply more and more logic about what kinds of changes we care about. But ideally, a stable release won't change the behavior unless that old behavior was a bug. So what was your question back there?
For Homu, can you
Yes.
hook it up to, what CI systems can you hook it up to?
Okay, question, what CI systems can you hook Homu up to? So, Homu proper was primarily a BuildBot thing. The servo fork of Homu works great with BuildBot, Travis CI, and AppVeyor, because Travis can run your Windows and Mac builds, and AppVeyor runs your Windows build. Or Travis can run your Linux and Mac builds, sorry, and AppFire runs your Windows builds. So we can get cross-platform coverage by combining those test results. And then also obviously the BuildBot results as well, because with our own BuildBot infrastructure, we can run even more stuff than we do on Travis. Yeah, question?
What's your approach to making sure non-core things don't go stale? I've always had the problem that developers care about making the code work, so things like the welcome bots, how do you make sure that the content in those doesn't just kind of get aged out and irrelevant?
Okay, the question is, how do you make sure that the non-code stuff doesn't go stale? That he's always had the problem of welcome bots and stuff kind of gradually becoming irrelevant. There's a couple cool things that I didn't actually even brag about in here. So one of them is that we have, in our docs, if you use RustDoc, you can actually test the docs as code. And if the code in the documentation, the code snippets, is invalid, then you'll get errors.
Right.
So that helps with docs. What helps keep High5 and the other welcome bots up to date is just you'll see them constantly. And if a reviewer, so if a newbie does the wrong thing based on the High5 message, we'll ask them why they did that thing, and if they say, oh, High5 told me to, or if we notice that it's misleading, it's easy to just throw in a PR and fix it.
And that's considered a responsibility of the developers, or do you have people who are dedicated to doing this?
The question is, whose responsibility is it? I think it's, well, nobody's really all that assigned to it, but it's in our own self-interest to keep the welcome bots as useful as possible. Otherwise, we're going to have to answer the same question over and over.
Right.
And I feel like the community is sufficiently convinced that we should be offloading everything that we can onto bots, that there's rarely the argument that a simple piece of automation isn't worth the time.
Thank you.
Yeah, more questions, things you hope to learn here that I didn't cover, any of the above. Awesome, well thank you very much for coming, and I would encourage you to check out the tools that I've mentioned. I'll stick these slides up online, and I would encourage you to consider automating the boring stuff that you do.